Hey, I'm Chris Zepp from Make Everything, and today we're going to be talking about welding for woodworkers. Check it out. So welding is an incredible skill that is so versatile and useful, especially if you're a furniture maker or a woodworker. I meet plenty of woodworkers that want to get into it but have no idea how to get started. So I wanted to make a video just sort of sharing some of the very basics of it, explain the different processes of welding that you may have heard of, and also give you just a little bit of background as to how best to perform them and how your woodworking tools and your woodworking skills actually play heavily into welding and metalworking, and it's not that hard to get into it. Now, the four basic types of welding you've probably heard of are MIG, flux core, TIG, and stick. Now, they all kind of do the same thing. They run electricity through an electrode and they add material to a joint of metal, and they can blend those pieces of metal together, and when you're done, you can wind up with what is essentially one solid piece of metal throughout. Now, obviously, unlike woodworking, there is no glue involved, but also unlike woodworking, your joints don't have to be perfect. If you have a gap in woodworking that's 1/8 of an inch and you want to fill that with glue, good luck, maybe with epoxy, but definitely not with regular wood glue. And that joint is going to be strained if there is any gap in between. With welding and metalworking, we don't have that problem. You can fill gaps probably up to 1/4 of an inch, if not larger, and you really get away with a lot more, which is really nice, especially if you're a novice and you maybe don't have the most precise tools to do it. Now, I learned how to weld while I was in art school, learning sculptural welding, and then I moved into my shop and I had to pick up welding quickly while doing projects and, doing commissions for customers. It's a great process. It's very easy to learn, and I'm going to go through those basics on this machine, starting with MIG welding, but first, we'll talk a little bit about the machines and safety. So like any process in the shop, safety is very important. That's why we're going to start there. Now, when you're welding, you're creating a very bright ultraviolet light. So the big thing you want to protect is your eyes. Now, this is an auto-dimming welding hood. So basically, when that bright UV light and that arc is struck, the lens in here responds to that by dimming to a certain shade inside. Now, these are available by a million different companies in a variety of different shapes and sizes. Some of them are auto-dimming, some of them are just a fixed shade, but you want to make sure you get yourself a welding helmet. And if you're a beginner, I don't recommend getting a fixed shade. Spend a couple more bucks and get yourself an auto-dimming helmet, because it will absolutely make your life easier. If you try to look through one of these with a fixed shade and you're not an experienced welder, it can be very difficult to get started. Also, you get kind of what you pay for with welding hoods. I like these Lincoln Vikings a lot, and I wouldn't go ahead and cheap out to buy the cheapest hood you can. You'll definitely have a better experience if you get a little bit of higher quality hood with higher quality glass in it. Now, aside from the welding hood, I'm also going to protect my eyes with clear glasses underneath my welding hood, just because you do have sparks that can get up underneath the hood. And then I'm already wearing long sleeves because it's a little cold in here, but I'm going to be wearing a fire-resistant jacket and also some nice leather welding gloves, which are going to keep my hands from getting burned. I also have jeans on and boots. It's very important that you protect your body when you're welding. The ultraviolet light actually can give you a sunburn, and you find that happens to a lot of guys that work out in the field. You get it right on the underside of your elbow, and it is very uncomfortable, I promise. While we're talking about safety, one of the struggles that people have when it comes to welding is they don't have a big metal table to weld on. Now, I have a 4 by 8 steel table, which is great because I can ground to it, and we'll talk a little bit more about that as we get into the machine setup, but you don't need that. So for today's examples, I'm going to be doing all this on a piece of 3/4 inch plywood so that you can see that you can easily weld projects together on a wooden table or a wooden workbench. A lot of guys wind up welding on the floor if they have to. One of the things you want to be aware of, though, if you're welding on a flammable material, is that an ember can definitely get into this and smolder and start a fire. So you're going to want to make sure that when you're done welding for the day, you give yourself at least a 30-minute fire watch. So that means you're done welding and you stay in your shop for at least 30 minutes to make sure nothing's smoldering. Keep an eye out for smoke. Always keep a fire extinguisher or some water nearby so that you could put out a fire just in case you have one. Let's look at the machine. All right, so here I've got two different MIG welders. Now, they're both multi-process welders, which is not every type of machine that you can find, but these are a good beginner machine that I recommend. So this is a Lincoln 140 MP. The MP stands for multi-process, and this is a 215 MPI, same thing, multi-process inverter machine. Now, when I say multi-process, what I'm talking about is those four types of welding that I mentioned earlier. You've got MIG, flux core, TIG, and stick. Now, both of these machines can do all four of those processes, and they can also weld with a spool gun. If you're not sure what a spool gun is, it's essentially a way to weld aluminum with a MIG welder. I just did a video where I fixed a boat with one. You can check that out for sure. Now, the difference between these machines is this one is a 110 only machine, and this machine can do 110 or 220. Now, a lot of people, when they're thinking about starting welding, they tell me, oh, well, I don't have 220 in my garage. I can't do it. This 110 machine is very capable. I do a lot of work with this. Obviously, it's not going to give you the power to weld thicker material, but with enough beveling, you actually can do a lot of work with a 110 machine. And what I like about this one is that if I have to take it off site or I have to use it in a different area of my shop, I can plug it into either 220 or 110 and I can get a lot of work done with it. Now, essentially, they're the same under the hood. They use a spool of wire like this if you're MIG welding, and this is a coated steel wire. This is going to feed out through the machine, and this is going to be your filler metal. This will go inside the machine. You can use spools this big, smaller, bigger, stuff like that. And these are both going to be able to be hooked up to gas. Now, I know a lot of beginner metal workers wind up with a very inexpensive, like 125, or they call it a 110 or a 120 flux core MIG welder that can't use gas. Now, those do have a purpose and they do fill a certain need, but from what I've found is generally they're a waste of money. They're very, very cheap. They don't put out a lot of power. And most of the people that come to my shop or came to my shop to learn how to weld that had one of those, when they use one of these more powerful machines, they totally have a different experience. So if you're gonna buy a welder, I would say shy away from the cheapest one you can get and save your money to buy something a little bit better. Let's look inside the machine. I'll show you how this is set up. Now, one of the things I mentioned when I was talking about different processes was flux core welding. It's commonly misnamed as also MIG welding, but it's not. MIG welding has gas in the name. Flux core welding does not use gas, and that's sort of like the first foray into welding that most people have. Now, I have a flux core spool already in the machine, and that's the process that I'm going to show first because I feel like some people are familiar with it. And what we've got in here is we've got a spool of wire that gets fed through some rollers and then gets pushed out the end of a MIG gun. Now, I say pushed out. It's very important to know that because this wire is not pulled through the gun. It's pushed all the way from back here. So if your welding lead is kind of bound up, or let's say you're welding in your garage and you park a car on it, you're going to be restricting the area that this wire has to travel through. Now, it's a very flexible, thin wire, so if you restrict that area up by making a really tight kink, you might wind up with some jamming, so you want to make sure that your lead is as straight as possible. Now, these machines are very safe, but obviously when they're powered on, you don't really want to be touching too many of the components in here. That being said, inside the machine, there's also a chart showing all of your parameters, your voltage and your wire speed. In this particular machine, we've got a nice digital display on the front that's going to show us everything we need. But if you're ever not sure how to set your machine, 99% of welders, every welder that I've ever used, had a chart either inside the door or outside the machine that told you how to set it based on your process, your wire, and your thickness. So let's look at the front of the machine, then we'll do some test welds. So for illustration purposes, we're going to be using this Power Mig 215 MPI because it's got this nice digital screen and it'll allow me to kind of show you through the process a little bit easier. Now, I was TIG welding with this, so I'm going to back out all the way to the home screen to start over. So on this machine in particular, we can do those four processes I was talking about. We've got MIG steel C25, which refers to the gas, MIG steel C100, also referring to the gas. We've got a manual mode, we've got a flux cord mode, spool gun, stick, and TIG. Now, because a lot of people are familiar with flux core welding, we're going to start there, and then we're going to move to MIG, stick, and TIG. So if I were to select flux core, it's asking me to set up my electrode. So now your electrode, when you're welding, is essentially the part of the welding setup that's going to actually be interacting with your metal. In our case, our electrode is the wire that's sticking out of the front of our MIG gun. Now, when we're setting up a machine, you have to set the polarity of the machine. Now, when you're flux core welding, you're actually going to be electrode negative. So we're going to take our electrode lead here and we're going to hook it up to the negative side of our machine. And then we're going to take our ground and we're going to hook it up to the positive side. This is the ground clamp. It's very safe. People are generally intimidated by these because it looks like a Frankenstein thing, but this has to be in contact with your work in order for this to weld to it. So in our case, we're going to be using a wood table, so we're going to be clamping right to the material, not to the table itself, and we're going to make sure this is touching it. If I select through, it's telling me that I have no gas required, so I can keep going. Then it's asking me the size of my wire. Now the wire we're going to be using is 0.035, which is a great general use wire, and then the thickness of my material, which in this case is going to be 12 gauge mild steel, and then it's going to automatically set our values. So let's look at the material that we could use on this. So in general, when I'm welding, especially for furniture making, I'm using some square tube. Square tube is easy to cut, it's easy to miter, it's just like working with a piece of wood. You can cut 45s and you don't really have to worry about trying to weld around a round object. Now you can obviously weld tubing, but in general, here are some sizes for reference. We've got some 2x2, some 1x2, 1.5 by 1.5 inches, and 1x1. Now these are all 1/8 inch wall, and this is a 16th inch wall. Now when you're beginning and starting out, I recommend going with an 1/8 inch wall tube just because it's a lot more forgiving. You're not going to burn through as much. The 16th wall stuff like this can definitely very easily burn through it, and then you got to fill a bunch of holes. Now for the examples that I'm going to do today, I'm going to use this 1.5 by 1.5 with the 1/8 inch wall. I really like this for furniture. It's got a nice dimension if you're using like a 3/4 inch thick board like this, and you can really make really strong stuff out of it. It's one of the benefits of working with steel is that its strength to weight ratio is really, really good. You can make a lot out of this, and this will support a ton of weight. So for prepping this material, I've got these two pieces of 1.5 by 1.5. I've got a very cheap $20 Harbor Freight grinder, but what I have on here is a good abrasive. Now, the grinder doesn't matter, the abrasive definitely does. You can use these cheap grinders. I've used these hundreds of hours, and they'll definitely give you their money's worth, but buy yourself a better abrasive because those will wear out really quickly if you go with the real cheap ones like from Harbor Freight. Now prep is pretty important. With flux core it's not that important, but you've got mill scale on this tube and you've got a burr here on the end. So what we want to do is just clean this off before we weld it, and I'm going to show the flux core welding process so you can kind of see how it looks, and I'll explain why it's not my preferred method, especially for beginner welders, once we get a little bit further into it. So for clamping of metal, you don't need anything special if you already have clamps for wood. You can use the same exact clamps. The only thing you're going to want to be aware of is if you're using plastic quick grips, that plastic will melt if you get too close to this. One of the things you have to worry about when you're welding is heat deflection. So if I were to weld this side only and not clamp this at all, what's going to happen is this piece is going to bend up and it's going to move up towards that initial weld. That's why you hear the phrase tack welding something very often. So normally what you would do is you would tack weld on all four sides so that you're introducing just a small amount of heat, and then you could weld everything else, and then the tack welds would make that resist its movement. Now I'm going to weld this without tacking it just so that you can kind of see if there is any heat distortion, and we're going to do that flux core gasless weld. One of the things about flux core welding is it produces a lot of smoke, and the smoke is not great to breathe. So you want to do this in a very well ventilated area. In my case, I've got a fume hood right here, which is going to be sucking up that smoke, but if you're doing this in your garage, you want to make sure that you've got a nice cross-ventilated breeze so you can get that smoke out of the air, and definitely try not to breathe it. So like I said, if I go to weld to this without actually grounding the material, and I can pull the trigger, nothing's going to happen. So in order for me to get that arc to start, I'm going to have to be grounded to my material. In order to do that here, I'm just going to clamp my ground clamp right to my metal, and we're going to weld around this. Now I'm going to do a full bead on this first weld, and I'm going to show you what it does to the back side of the weld by introducing all that heat on the top. So you can see when I'm gasless flux core welding, it's a very violent arc, and there's actually some slag and some kind of yellowing on top of it. Now you can get that slag off with a little chipping hammer or a little wire brush. And if we look at the back side, we didn't get a lot of heat deflection here, but it definitely opened up this joint a little bit. Now if I was going for a very precise build here, I would have wanted to tack it all the way around to keep it from moving. Now I'm going to weld around the other corner so you can see a little bit more of that technique. And then we'll grind it a little bit so you can see what it looks like after it's ground. So even though this is a gasless weld, I wound up with a pretty good weld. I think I was running a little hot here, and it's a little undercut, and the inside corners came out pretty good. Now, if I wanted to grind this flush, I'd want to make sure that that weld was sticking up just a little bit above the base material so that I could grind it back down. Now, be careful when you're flux core welding because some wires can be welded over and some cannot. This wire can be welded over, so if I wanted to make this flush, I could weld another bead over top of it, then grind this all flush, and it would look great when it was painted. Now again, flux core welding is a great thing to do. It's actually great if you ever need to weld in a windy area because you don't have that gas in the way. And it definitely can get you pretty far, especially when it comes to welding over mill scale. But for beginner welders, I recommend regular MIG welding with C25 gas. So let's take a look at that and then we can compare the two. So switching your welder from flux core to MIG is really easy. It only takes a couple minutes. Now that we've switched out the wire, we're back out to the menu. We're going to select MIG Steel C25. Now the C25 refers to the gas, which is a 25% CO2, 75% argon mix. And I'll show you the regulator and the gas bottle in a second. If we select this, you're noticing that it's telling us to switch the polarity from electrode negative up to electrode positive, which is ground negative, which is a little more standard for regular MIG welding. And it's also making sure that we have the MIG gun selected versus the spool gun. Saying the gas that we're using, 7525. It's asking us the size of our wire, which in this case is 035, which again is a great beginner size wire because it puts down a lot of material. And we're going to set our thickness to the 12 gauge tube, and it's got our parameters already set. Let's look at the gas bottle. So here we've got our regulator on top of our C25 gas bottle. Now I've got this little widget up here that tells me if the gas is open or closed, so I don't forget to close it. Now, a lot of people are intimidated when it comes to MIG welding because they don't want to get the gas. They tell me, oh, I can't have gas at my shop or I can't have gas in my garage. I personally feel that this gas bottle is less dangerous than the propane tank in your barbecue. This is an inert shielding gas that's in here. And if it does leak out, it's not going to poison your whole family overnight. You do want to make sure, though, that all your connections are tight. And if you shut this thing when you're done welding, you'll make sure not to lose all your gas in between a Saturday and a Sunday. That happens to a lot of beginner welders. They run out of gas because they forget to close their bottle. So this little view handle thing helps you know that your gas is open. Shut it at the end of the day. You've got two gauges here. One is for your tank pressure and one is for your output pressure. Your tank pressure is going to read about 2,000 PSI when you get it new from the welding store, which just should let you know that this is a very high pressure cylinder. So be very careful. If you were to knock this off, this thing is like a torpedo. Chain it to the back of your machine or chain it to the wall or the leg of a workbench if you want to be really safe. Now, when we're setting our output pressure, you want to make sure you do it while the gun is actually putting gas out. Now, if I were to adjust this knob, you can see that that gauge is moving, but I want to make sure that whatever my pressure is set at, it is doing so while I'm actually having gas come out the front of the MIG gun. If I were to set this while the gas is not flowing, when I actually pull the trigger, I might not get the same result. So you want to make sure that you're pulling this while you're adjusting that. Now let's go over to the material and do a test weld. So we've got the same 1.5 by 1.5 mild steel here. Now, since we're using a solid wire gas weld, we want to make sure that we clean some of this mill scale off. My buddy Jody from Welding Tips and Tricks just made a great video about the difference in welding without grinding off mill scale and with grinding off MIG scale. And if you want to learn about welding in general, especially really good techniques and practices, check out his channel here on YouTube, Welding Tips and Tricks. I've learned a lot from him in his videos, and he's just a great guy. So I'm going to grind some of the mill scale off and prep these things to be welded together. Now again, I'm going to be welding this without clamping it because I want to show the effects of the heat can have on a welded joint, especially if it's nice and tight when you start if you don't clamp it. Same process though, we're going to need to be grounded. In this case, we're going to ground directly to our material. And the first thing you should notice when I do this MIG weld is that it's a lot less smoky and a lot less violent than the flux core. So a lot less smoke, but just as much heat. You can see the smoke coming off this. Now, this didn't actually really open my gap up that much, but if I let it cool, it likely will. So I'm going to weld the backside quickly and move around to the other corners. I'm gonna grind this weld flush so you can see how clean of a joint we've got between this piece of metal and this one. Now this piece is still hot, but you can see I've got a really nice flat joint there. And if I had to dress up these inside corners, it wouldn't be too bad. I got a pretty nice weld in there. This one's not as good, and a pretty nice weld in there. Now I've got a whole video on my channel showing how to grind inside corners like this and make them smooth. Now you can see how nice of a weld we got with that solid wire and that gas MIG weld. Personally, I like it a lot more than the flux core weld. Now, to show the other two processes, we're going to do some TIG and some stick welding, and you can see the difference between all four. All right, so here we've got a stick electrode on what is commonly referred to as a stinger. Now, this is your welding electrode. This is going to be burning back as you're welding, and this is the simplest and I think earliest real form of welding with electricity versus gas welding. Now, this obviously still needs to make a through connection through the ground. So we're going to make sure we ground to our material. And this right here is a 7018 rod. There are many different types of stick rod for many different applications, and there's a ton of great videos on technique. Now, if you have a tombstone welder, which looks something like this, in like your dad's basement, this is what you would do with it. This is stick welding. It is more of a structural weld. It is very, very down and dirty, low tech. You've got no gas required. Everything you have is right here on the electrode. There is flux coating this electrode, and it's going to be burning away as we weld. We don't really need to clean off mill scale, and it is going to produce a lot of high energy sparks and a very, very bright light and a lot of smoke. So we're going to make sure our fume extractor is close, and I'm going to attempt to stick weld this. Full disclosure, I am not a great stick welder. So you can see on my wood table, I had a little ember burn up. Now I'm going to keep an eye on that, but you want to be really careful if you're welding in a room that's filled with wood. All right, so you can see the difference there. Now, the issue that I have and a lot of beginner stick welders have is actually striking that arc. I have a hard time getting that technique down, but once I get going, I do all right. Now, this piece is extremely hot. This puts a lot of heat down into the material, and you can see, at least in my case, it's a little bit harder for me to control that weld, and my first weld turned out absolutely terrible. I'll try to grind this out so we can see what it looks like. So not so great, definitely not as nice as this MIG welded one, but if you had to stick two pieces of metal together, you can get by with stick welding. Now, last but not least, let's do some TIG welding and we can compare all four. So one of the things I like about this machine is that it has what's called a TIG solenoid in it. So if we go to the TIG selection on here, it's going to tell us to select our electrode on the negative side. Now there's a hole in the end of this TIG electrode, and in there is actually a little gas port. On the back of this machine, there are two spots to hook up gas, one for the C25 and one for 100% argon. When you're TIG welding, no matter what the material, and generally, you're going to want 100% argon, so it is a different type of gas than you are when you're MIG welding. Now, I have a foot pedal which controls the amperage, and that's hooked up right here, and we're going to be using a 3/32 tungsten. We're going to set our machine to the 12 gauge, and when I press the TIG pedal, it's going to start the arc through the TIG torch. So with TIG welding, we want our material to be very clean. we're going to be striking an arc using just this little tiny tungsten electrode here in the end. Now, the other thing about TIG welding is that TIG welding is a two-handed process. So what we're going to have, as opposed to a wire coming out the front of a gun or an electrode being on the end of a stinger, is we're going to have our TIG torch essentially creating an arc, and then we're going to be feeding a filler metal that's the same material as the base metal in most cases to actually fill in and create that welded area. Now, the nice thing about TIG welding, and one of the reasons that I really like it, is that you can do what's called fusion with it. So if my joint is nice and tight, I can actually manipulate one piece of metal over onto another without adding any filler metal. The thing about TIG welding that's really great is that it doesn't really create sparks. It's very delicate, very precise. You can create a really nice joint that sometimes doesn't even need to be ground before it's painted. Now, TIG welding is something that you absolutely need to practice if you're going to get good at it, because it's definitely an art that you need to perfect. Now, I practice a fair amount, but I'm not the best. I'm going to clean up these pieces and then we'll TIG weld these together. One other thing to note about TIG welding is that you can very easily sink a lot of heat into a piece of material with this. So I'm not going to tack the other side, and I'm going to show you how much this tube is affected by the heat that we're able to put out through this torch. So the first thing I'm going to do is I'm actually going to fuse this piece with that piece without adding any filler metal, so you can kind of see how that works. The other thing to note is that this is a scratch start TIG, so I actually have to touch it off on the material in order to get it to start the arc, and then I can pull it together. I'm also grounding directly to the material on this. So what I was able to do there was heat up the base metal, and I was actually able to pull some material from here and push it onto this. Now, I haven't added any material to this weld at all yet, but I have been able to fuse these. So if you have a really tight joint or a really tight gap and you want it to be super precise, sometimes you can get away with just using fusion and not adding any base metal. Now I'm going to weld the rest of this gap. We can see how the heat affects it, and I'll try to work my way across this. So like I said, there are no sparks in this process. It's very controlled and very delicate. And if you get good at it, you can actually manipulate your weld to look a certain way and have a design to it that maybe you want to get painted. Now, I put a lot of heat into that, and I've opened up this back side. Now, it's a little bit more difficult to fill gaps with TIG welding, but it's definitely possible. So I'll weld this side and close up whatever gap I might have made with that heat. So I'm running a little hot. I think I'm undercutting a little bit, so I probably want to turn my amperage down, but I'll weld these inside corners and we'll look at it compared to the other ones. So now in this case, I tried to start a weld here, but I really wasn't in a good position, so I stopped. I should be able to use my torch to melt over that base metal that I left there, that little bit of filler rod, and continue to actually make a acceptable weld on this inside corner. So I've put a ton of heat into this using this torch, and generally it's because I'm also moving very slowly. Now for me, the two-handed aspect of TIG welding is really the most challenging part, because I have to support my arm and try to make consistent movements while also filling in that filler metal. So like I said, it's an art that you 100% have to practice. And if you do try it and you're not good at it, don't worry, keep practicing. I clearly need some practice, but like with any type of skill, you're gonna need to work on it in order to get better. And I like to practice as much as I possibly can. All right, so that sort of runs you through the 4 different types of basic welding, especially all the things that I can do with this one machine. But like I said, I prefer a gas MIG weld for beginners. I think it provides the best result. I think it's the easiest. It's the easiest to grind, and especially if you're trying to make furniture, if you're a woodworker and you're trying to get into this and you don't want to fuss around too much with a difficult process or a lot of smoke, I would just make the investment and get a gas solid wire MIG welder. I really like these results. You can get nice inside corners and you can do a lot with this. Now that being said, if flux core is your only option, you can get a pretty acceptable weld, especially with some practice, and you can grind these out and make them look really, really smooth. For those that are maybe using an older welder or just trying to get into it with something that they have, stick welding you can obviously do. Like I said, I'm not that great at it, but with anything you can learn. And then all the way up at the top, you can definitely get your hands on some TIG welding. This piece is still hot considering how much heat I put into it, but if you're good at it, you can get a really, really nice weld that a lot of times if you're gonna powder coat, people won't even bother grinding them out. I like TIG welding, especially if you're in a less commercial and more residential environment, because it's very, very quiet and most people won't even know that you're doing it. It's also a really great skill to learn because with TIG welding, you can really proficiently weld stainless and aluminum, and that's a really great skill. So like I mentioned earlier, if you're a woodworker already, you probably have a lot of the stuff that you could use to jig up and work on a metal project, especially a welding project. Now I was cutting off on my wire with these MIG welding pliers, but you don't necessarily need to use those. Any wire cutting pliers can be used to cut the wire that comes out of the end of the gun. And I used a very cheap $20 angle grinder. If you want to jig up 90s, you can use any of the 90-degree jigs that you would normally use for woodworking. And I really like using 1, 2, 3 blocks as kind of setup blocks. For clamps, you can use welding clamps like this, which are kind of like a vice grip style. I buy these in packs on Amazon. I'll throw a link down below. But honestly, you can get away with using quick grips like this or just regular cheap F-style clamps. The only thing you have to be aware of is that you will melt these little rubber ends, but in most cases they pop right off and you can just use metal to metal, and you can definitely get a lot out of these. One of the things that I kind of try to tell beginners to avoid is those little 90-degree magnets. Personally, I don't feel like they have enough grab to really grab a 90-degree corner, but with something like this, you can drop 2 pieces of metal in there, you can get a really good clamp on them, and you can weld around it, basically all the way around it while it's still clamped up, and you want to let this cool before you're releasing it from the clamps to try to reduce as much warping as possible. All that being said, I've made jigs out of wood. I've made jigs on the floor. You can really get away with a lot when you're welding. Just obviously be very careful of flames on any wood surface. So when it comes to welding, I think it's super important for woodworkers, makers, metal fabricators that don't weld, anybody to know at least the process and what you're looking at when it comes to welding. I think it's a skill that every woodworker should learn because it can absolutely save you time in your business and maybe cut down a high lead time item like a table base or a bracket, stuff like that. I make that type of thing for cabinet makers and furniture makers all the time. There is no shortage of work in the leg making business or in the shelf bracket making business because a lot of people just don't know how to weld. One of the things that I think is important, though, is to understand the different processes of welding, because if you're going to bid out work and have a subcontractor like a welder do something, you should know if they're MIG, TIG, or stick welding the product, because then it'll maybe identify a little bit of what kind of quality you can expect and whether or not you're going to be able to send it right out to paint or if you're going to have to do any grinding or finish work. Welding has been a huge part of my business here at Make Everything. It's been something that I've been able to kind of transform my way into. I was a woodworker far before I ever did any metalworking, and for me, learning how to weld was like finding lightning in a bottle. I find that welding and metalwork is the highest hourly rate that I can charge customers if I'm just doing time and material work, and I find that most of the creative and fun jobs that I want to take on involve welding and metalwork of some kind. So I really encourage you to try it out. Like I said, most of the woodworking stuff that you're already used to using applies here with welding. Just you have to be very careful of the sparks. You want to protect your eyes, you want to protect your skin, you want to protect your shop, and always make sure you have a fire extinguisher nearby, some water. You want to make sure you're well ventilated so you're not breathing in a bunch of unnecessary smoke. So for this whole video, I used the Power Mig 215 MPI. It's a great welder that just came out onto the market, and I really think it's a great beginner or even professional grade machine because you can do all 4 process, and it is that 110 and 220. I've enjoyed using it. I've actually been using it for a while, And for some price point reference, this retails for about $2,000, and the smaller machine that I showed you, the Power Mig 140, retails for about $1,000. You can get the gas at an air weld or any other local kind of gas supply to you, and these gas bottles last a really long time. Typically you lease them or you kind of bring them in cycles. As long as you close that bottle at the end of the day, if you're a hobbyist welder, you will get a lot of trigger time out of one of these gas bottles. So make the investment into your business. It is almost definitely going to pay off, and I promise you that you'll never wish you didn't learn how to weld. I hope you enjoyed this video. If you want to see what I'm doing on a day-to-day basis, follow me right here at Make Everything Shop. I post daily updates on what I have going on in the shop, projects, and a little behind the scenes as to what I have going on here. There's always an interesting project coming, and I really do enjoy that. If you're interested in any of my Make Everything merch, I've been getting a lot of inquiries on to where to get sweatshirts, t-shirts, and stuff like that for the holidays. You can check out my website, makeeverythingshop.com, and there's a store there that you can buy t-shirts, hats, and stuff like that. And I also make these fraction to decimal conversion charts, which can be super helpful on your machines, or I personally keep one on the back of my phone. It's a really good way to kind of make sure that your fraction to decimal to millimeters is all in check, and I use it a lot when I'm drafting and when I'm doing work over here in the shop. If you enjoyed this video, please give it a thumbs up, and don't forget to subscribe to my channel if you want to see more videos like this. And if you have any tips and tricks for people, leave them down below. I really encourage people to kind of discuss things in the comments and let me know if this video is helpful to you and if you want to see more videos like this. I've been thinking about doing sort of a table-based build-along where I just build a table base with very simple flux core welding the whole way through, grind it out, and then paint it so you can see the process. If that's something you'd like to see, leave a comment down below. I hope you enjoyed this video. I enjoy making this kind of stuff and bringing metalworking and welding to a new audience. So let me know what you think, and I hope to see you on the next one. Thanks.